Welcome to June's Leetcode Challenge. Today's problem is h-index 2. Given an array of citations sorted, write a function to compute the researcher's h-index. According to Wiki, an h-index is where h of its n papers have at least h citations and the other h papers have no more than h citations each. So that's a wordful. It's confusing, and frankly, I think I would not even concentrate on that definition. Here we can see an example that 3 would be the output because 3 is where we have at least 3 citations. And we want to solve this in logarithmic time complexity. So I was able to solve this problem, but I have to admit that I didn't quite understand what was going on here. It's confusing to say the least, but I'll start off with thinking about what do they mean by h-index. So here are the number of citations in sorted order. At the very first point, we know that there's at least 5 papers with 0 or greater citations. Here we know that there's at least 4 with 1 or greater, and so on and so forth. And because it's sorted, all we have is just the index number, or the length of the array subtracted by the index number. It can give us, you can think of these like the h-index. Now, if we were to do this linearly, what do we want to find? Well, we want to find the maximum number, right, at which the h-index is less than or equal to the number of citations. So take from here, h-index 1, we have 6. So that would count, but we want to find the maximum h-index, right? So 2, 5 is greater than 2, so 2 would count. 3 is greater than 3 or greater or equal to 3. But 4, that is the point at which 1 is less than 4. So that doesn't count as the h-index. So the maximum number here would be 3. So that's interesting because we find a couple points that we need to understand, that we're not returning the index number. We're returning this h-index. We're returning h-index. So that's point number 1. And we want to do this in logarithmic time. So we can't just go through it linearly. Well, say that we want doing a binary search. What's the point at which we know that this h-index is going to be the last one? So we could basically have 2 pointers, one at the left and one at the right, check the middle, and say, hey, is this value greater than or equal to the h-index? And we know we can calculate the h-index by simply getting the length minus the index number. And if it is, then we know that we could move our right pointer to the mid. Otherwise, we move our left pointer to the mid. And at some certain point, it's going to be pointing at the 2 where one of them is breaking that condition of 1 being greater than or equal to the h-index. And we want this left pointer to then go to the right side. All right, so let's initialize some variables here. First, I'm going to get the length of citations. Now I want the left pointer, which is just going to be 0, and the right pointer, which is going to be n minus 1. So this is the same as any other binary search. While L is less than R, usually we check to see if this midpoint is fulfilling our condition, right? But unfortunately, we need to find the maximum h-index, or in other words, the maximum index number at which this condition is true. So we have to actually go through this whole loop. There's not going to be one condition that we can check at that midpoint to return immediately. So L plus R. Oops. So we'll calculate the midpoint and we'll check if, let's see here if I get this right, citations mid, if it's greater than or equal to the H index, which is going to be n minus mid, well, then we know we can move our right pointer. Otherwise, move our left pointer to the mid, and we're going to have to add 1 because of that last condition where we want that left pointer to go to the right. Finally, we want to return what? N minus L, which is going to be the H index. One base condition we might have to check for is if we are given a empty list, we'll just return 0. And there's actually one other thing that we need to consider, where what if all of these were 0? Because if that's the case, there's no H index that fulfills this condition, but it's going to point all the way to the end here, and we're going to return 1. So in order to just get rid of that funky case, I'm going to say if citations L, if that equals 0, that doesn't make any sense, so there actually is no H index. We just return 0. So let's submit that. And it did get accepted. Now, I kind of hesitated putting out this video because I did get this, and I was quite proud that I did, but I have to admit I don't quite understand what's going on here. Like, I have some intuition of why this is the case, but this definition of the H index is really confusing. It's probably better to say find the maximum number of, find that number where that's his maximum number of papers with the maximum number of citations, or something like that. I feel like it could be described better. So this did get solved. Maybe you guys can find a better explanation, but check it out, because I read the discussions after I solved this, and I still couldn't find one that explained it better to me.